the great news about this lesson is if you could do that opener, you can do every problem in this lesson. So, the next problem is asking to solve a quadratic equation by factoring. And then I'm going to tell you that you can always check these, solve the equation by graphing. You can always check by factoring. So, here, I'm given the equation. X squared plus 2x is equal to 8. And I want to solve that by graphing. The very first thing is I want to write it in standard form. The important part of standard form is it must equal 0. This is very similar to problem 2 in the opener when you solve by factoring. So I'm going to subtract 8 from both sides and get x squared plus 2x minus 8 is equal to 0. So now I want to graph the related quadratic function, which is just take, in this case, the left-hand side. I want to graph y is equal to x squared plus 2x minus 8. So we're going to do exactly what we did in number 1 in the opener. I'm going to find the axis of symmetry. X is equal to the opposite of b over 2a. So in this case, that's negative 2 over 2 times, there's no number written in front of the x squared, so it's a 1. 2 times 1 is 2. So once we simplify this, x is equal to negative 1. So if I want to find the vertex, same as in problem 1 in the opener, I'm going to plug in this negative 1 wherever I see an x. So it'll be negative 1 squared plus 2 times negative 1 minus 8. So negative 1 squared is 1. 2 times negative 1 minus 2 minus 8. So that's going to give me the vertex of negative 1 comma 1 minus 2 is going to be negative 1 minus 8 is negative 9. So I'm going to plot that. Negative 1, negative 9. It's right there. I'm also going to plot the axis of symmetry as a dashed vertical line. Okay, so now we're going to estimate the x-intercepts. I'm also just going to quickly, my c here is negative 8, so that tells me that my y-intercept is negative 8. And so I can plot another point here. So if I want to keep doing this, I can go over 1, up 1. Over 2, up 4. So it's over 1, up 1 squared. Over 2, up 2 squared. Now it's over 2 from the vertex. Over 2, up 1, 2, 3, 4. And remember, if you did that on this side of the axis of symmetry, you can do it on this side of the axis of symmetry. Then I'm going to go over 3, 1, 2, 3, up 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. And that's going to get me to the x-intercepts. So over 3, well here, the axis of symmetry is right there, 1, 2, 3. And remember, from symmetry, that means go over 1, 2, 3. And I can now graph it. But this gave me the x-intercepts are the solutions. So this gives me the solution of x is equal to 2. This gives me the solution that x is equal to negative 4. So down here, x is equal to negative 4 or 2. And I'm going to check it by factoring. First things first, I didn't even give you the original. So I gave you this. So what I want to see is, does this factor? I want two numbers that multiply together to give me negative 8, but add together to give me 2. Well, a positive 4 and a negative 2, so x plus 4, x minus 2. And then I can set each of those factors equal to 0. X plus 4 is equal to 0, or x minus 2 is equal to 0. Subtract 4 from both sides. x is equal to negative 4, x is equal to positive 2, which is exactly the same thing I got by graphing. So, one thing to note here, if x is equal to 2 is a solution, x minus 2 is a factor of the quadratic. If x is equal to negative 4 is a solution, x plus 4 is a factor. So these are solutions. These are factors. So if a solution is, say, m, then a factor is x minus m. Okay.